Hello and welcome to the workshop or podcast, as you can call it, the importance of cloud security, protecting the future of digital transformation. I'm Natalia Ostashko and I'm here in the role of your host, and I'm also in charge of master's degree program at EPAM Systems that runs together with ITPU, IT Park University in Tashkent, the first online university in Uzbekistan. And I'm very happy that you have prioritized and found some time to join our session today. I'm here to introduce two of our guest professors who work in masters, and they'll be sharing with you the knowledge and expertise about the importance of cloud security. And if you decide to become the part of our academic and industrial community and join the study, I'll be happy to answer all your questions. And as we're having a very dynamic meeting, I'm introducing our speakers. We are happy to have Sergey, who is a security architect and the head lead at EPAM Systems, as well as guest professor of IT Park University, teaching in masters, and Alexander, who is a cloud security engineer at EPAM with a lot of projects behind him and a lot of expertise. And I'm sure we have the person who can speak in simple words about difficult questions. And while my colleagues are sharing with you the expertise, feel free to ask the questions either in Q&A session, which you can find in Zoom, or you can type the question in the chat. The third option, you can raise your hand, and at the section of Q&A, you'll have a chance to talk to our experts and discuss the issue which is crucially important to you. I zip now and pass my word to Sergey and Alexander.
Thank you very much, Natalia. Alexander, could you please start sharing your screen?
Yes, wait a minute, please. Hello, everyone. So let's start presentation. Wait a minute, please.
All right, guys.
Yeah,
all right,
we're
guys.
here.
Welcome everybody to today's podcast/webinar. So today's agenda will be all about cloud computers and the experience that we possess, both Alexander and myself. I've known Alexander for at least 8 years here at EPAM, and we've been doing cloud security only, right? Mostly, I would say mostly. And it's a really crucial topic to discuss here, and we'll be also touching on the topics that will be covered in the master's program. And by the way, Alexander is the course author for cloud security, both first and second level, the beginners and advanced level. All right, so the agenda will be what's actually cloud computing is. So before diving into cloud security topics, we need to kind of understand what is cloud computing. What's the worst could happen in the public cloud is not secure, right? So we'll use public clouds on your cell phones, on your computers, right? Online banking, Facebook, etc. So, and what you'll have a chance to answer to that question. Why should we be caring about the cloud security, right? So we'll talk a little bit about that. Do we trust operating services operating in the public cloud? So there are many services in the public clouds, and do we trust them, right? Initially, or should we do anything about them to secure it? What happens without proper security? So we're going to talk about in a little more detail. I'm going to discuss with Alexander because it's a pretty close topic that we explored in EPAM security practice. Back in the day, there was a famous Capital One hack that actually drove some of the major cloud providers to migrate to a new, more secure posture. So we'll touch a little bit about that. Yeah, so let's move on.
Alexander, Yeah, let's move on. So guys, here you can see more information about us. As for me, as it was said, I'm a cloud security engineer at EPAM. Totally, I have experienced more than 19 years at all. And I work at EPAM near 7 years, and mostly all this time I work as cloud security engineer. So I am AWS certified security specialist and AWS certified solution architect professional. So briefly, that is all about me. Sergey, several words
Yeah,
about you. Yeah.
yeah. I also possess those two certificates, and like certified solution architect professional level was very, very hard to pass, by the way. So, but yeah, we both possess those certificates in AWS specifically. So I'm a subject matter expert lead for the cybersecurity master's program. So I kind of oversee all of the courses, including cloud security, and cloud security is probably one of the closest to me, along with security architecture. So I'm the author of security architecture course in the cybersecurity master's program. I've been 12 years in cybersecurity, kind of started late, and 8 of those were in EPAM. And from the day one, I was doing cloud security. I mean, from my IT career overall, not in EPAM. Currently, at standard cloud security architect position, and developing lots of security tooling and pipelines and public clouds, specifically AWS. AWS is my favorite one.
Yeah, great. So let's move on. So guys, we have a question for you. Uh, so the question is, what is your current public cloud experience? We need it before we dive in. So we want to understand who is in the room today. Quick pulse check. What's your current public cloud experience? Are you brand new, tinkering in the lab, running workloads at work, or leading cloud project? There is no wrong answer here. Helps us to tune the pace and examples. So you have some time in order to share with us your answers, and I think we can move on. And now let's align on what we mean by cloud computing before we dig into security.
All
So
right.
let's,
The pop-up window should show up on your screens. I see 3 people already replied, waiting for
yeah,
the others. But we can continue. Please
yeah.
reply.
Let's move to next slide. So you see, the main question for us now, what is cloud computing? So cloud computing means renting computing services like storage, service, databases, networking, and software over the internet or on demand and pay as you go. In traditional IT, you manage everything: networking, storage, servers, virtualization, operating systems, middleware, runtime, data, and applications. With cloud models, responsibility shifts. For infrastructure as a service, IaaS model, the provider manages networking, storage, servers, and virtualization. You in the same time manage the operating system, middleware, runtime, data, and apps. For platform as a service PaaS model, the provider also manages the operating system, runtime, and middleware, and you focus on your code, data, and apps. For software as a service SaaS model, the provider delivers the entire app stack, and you mainly configure and manage your data and access. Think of it like housing. IaaS is buying a plot and building the house. PaaS is a condo where structure is maintained. And SaaS is a hotel. You just check in and use as the room. So now that we've framed the cloud, we can talk about the risk when security isn't done right. So maybe, Sergey, you have some questions related to
Yeah.
this slide?
Yeah. So just clarify, and as I'm seeing from the poll, there were 3 answers in total, and everybody answered no experience. So that's completely normal, right? Everybody is starting from something, and we started from not knowing what the cloud computing, cloud security is. But let me clarify a little bit what Alexander was just talking about. Basically the history of computing, right, from traditional IT, where the people used to deploy the computing workloads and services to basically data centers, right, to the hardware that they own or rent, right, from other companies. to the cloud computing model, and there are basically three different models, right? Infrastructure as a service, platform, and software as a service. And the differences here is the what's called the responsibility model, right? Where in blue is indicated what is you're responsible for as the client for the cloud computing, and what the cloud service provider is responsible for. As you can see, like for example, in SaaS model, software as a service, you can see that pretty much everything is a responsibility for a cloud provider outside of the software itself, right? So you supply the software in the form of code, right? Golang, C Sharp, Python, right? And you deploy it to the SaaS platform, and everything else taken care of for you. So the application layer, data, runtime, middleware, operating system, everything is covered by the cloud. So that's what cloud computing is. All right, so you got a second poll.
Yeah.
Let me launch it. Alexander, could you please?
Yeah. The second question will be, what is the worst that could happen if the public cloud is not secure? So we will discuss the topic on next slides, but let's please share with us your ideas.
Yeah, just think about it. Like even without having like extended experience with cloud computing, just try to visualize, right, the public service, public cloud service such as Facebook or YouTube, right, or something else, right, or online. Online banking application that probably most of you use on your cell phones, right? So those are all public cloud services, right? So think about what possibly could, worse can happen with your data, right? On the public cloud providers. We provided like a few answers per field. There is no right or wrong answer. Just try to do your best and respond to that. And I see 3 people also voted already. All right, so Alexander, please.
Yeah, let's move on. Let's go to next slide. So the next slide, as far as you see, will be about why should we care about cloud security. On the slide, you can see several schemes, and here you can see results of information which was shared by different companies. So according to a 2024 cloud security report, 71% of organizations experienced a public cloud-related security incident in the last 12 months. Another 23% weren't even sure that uncertainty itself is a risk. Why must we care about cloud security? Which problems can we face? So sensitive data protection. We store personal info in cloud, financial records, source code. So growing cyber attacks. Attackers exploit weak identities, misconfigurations, and human error. Ransomware and credential theft thrive in the cloud. The next important what we have care about is compliance mandates. So we have different security standards which are obligatory for the companies. It's GDPR, which is law in EU, HIPAA, PCI DSS relates to bank cards. So also we have to care about reputation at stake. One breach erodes trust that took years to build. So good cloud security is not a blocker, because very often people say that cloud security, information security stop business, stop everything. But we think that it's an enabler. It let us move fast, safely. And in next slide, we can check why we think so. We can prove it. So Sergey, do you have any
all right,
questions?
yeah, so we have responses from the previous poll. And interestingly, also 3 people responded. And I think those are the same people that responded to the first question, with all of them said no experience in public cloud. But all of them answered the closest, replied with the closest correct answer, which is, the question stood, what's the worst that could happen if the public cloud is not secure? And the best closest answer to the real world is potential data loss, compliance regulations, and or legal issues, reputational loss, and going out of business. Yeah, that's the closest answer.
Yeah, totally agree. It's the main problem we face today in clouds. Almost all companies.
And that indicates that our audience, understands how
Yeah,
cloud computing works and what threats that does possess to the people these days.
yeah, it's great. So let's move on. So the next question, we have already discussed it. We said about several words, but the main question here is, do you trust services operating in the public cloud? Here we asked mostly about Zoom, Facebook, YouTube, online banking apps. But what maybe I can add something here. What do you think? Is it safe to have government services in cloud? Because, for example, AWS, Microsoft, GCP are international clouds. I know that some countries develop their own clouds. What do you think about it? We share with you questions. Please answer.
Okay, the same. I think three people already responded. Thank you very much for quick response. So one response is okay. So we have four people. Nice.
Mm-hmm.
One has been engaged additionally. So we have two replied generally yes, they trust public services operating in the cloud like Zoom we're using right now, right? Facebook, YouTube, online banking apps. While others two said, I trust them only if they successfully pass the internationally recognized regulations such as SOC 2, ISO 27001, or GDPR, or PCI DSS, right?
Yeah.
So again, there is no right or wrong answer here. So most people, so I personally being like deep in security, right, and being paranoid sometimes about security, right, and on what data I can, post on websites, who is processing my data that I supply to the public services, right? But I generally don't question myself, like if I join this Zoom, what personal information can be shared by Zoom to others generally, right? Because it doesn't, even though it can be like a potential issue, but I don't really think about that, or Facebook or YouTube, but I try not to like post any sensitive information there. So, but I think the most correct answer is the second one. I trust them only if they successfully pass, especially for the services and applications that you submit sensitive information to, such as online banking apps, right? So you supply them sometimes password numbers, right? With you supply credit card, like for example, Apple Pay, right? So you put your Apple Pay application. That's a public service. That's an example of public service online banking app, right? So you supply your credit card information, including three CVS what is called CVS code, right? The three numbers on the back of your card. So and obviously Apple Pay, like Samsung Pay and other services, like well recognized, right, and well known, they pass PCI DSS specifically, and they pass ISO 27001 and GDPR and SOC 2, everything that was listed here, they pass successfully. You can check it. It's a publicly available information. But yeah, I would do like if like Zoom, for example, that I don't supply sensitive information right outside of my email, which in some instances like it's protected by GDPR, for example. But I don't really, I trust you generally trust. So like for like public available site that I don't supply information, I generally trust because I don't really care because I don't supply anything sensitive. But for like banking apps, yeah, obviously I would check the credibility of that service and what like regulation certification or attestations they possess for this year, right? Because like all of these certifications or attestations have to be passed each year, right? Every year.
Yeah.
Thank you very much for your response.
Yeah, thank you guys. And let's explore what happens when the trust is broken and cloud security isn't done well.
And that happens quite a lot, right? To be honest.
Yeah. So without good cloud security, consequences get real fast. So which problem can we face? Massive data breaches. So sensitive data gets exposed. It can be personal details, credentials, intellectual property. We also can face financial damage. So industry studies put average breach cost in the multi-million dollar range, higher for regulated data. We will share some of these cases later. So we can also face service downtime. Attacks or misconfigurations can bring system down, hurting customers and revenue. Also, it can be lasting reputation loss because trust is hard to rebuild after a breach. So most incidents trace back to a few themes: identity misuse, misconfiguration, lack of visibility, weak detection, and slow response. So we can jump to next slide and unpack a famous case that illustrates this. But I can say from a personal experience that almost so for all projects on which I worked previously and we work now, I can say that every day we had a lot of different type of attacks. We try to control it. We try to protect our companies, and I can say that for now we are in success. But as you will see it later, for some companies it can be a trouble.
Yeah, I fully agree to that, and everything that you mentioned for the identity configuration, misconfiguration, cloud misconfigurations, visibility, separation of duties. All those principles should be applied to the cloud service provider in where the organization wants to operate, right, and provide public services. But the truth is that all cloud service providers don't provide you with that out of the box, so it doesn't come with that by default, right? So you have a like Azure subscription, you have a AWS account, you sign up for it. There are some guidance, right, documentation, but they must be understood by professionals.
Yeah, it's
Even
still your
today,
responsibility.
exactly, it's still your responsibility. Even today, I was faced with what seems to be like a very simple problem or issue. It's not even a problem or issue. I just needed to patch an AWS EC2 Windows server running Windows Server 2022. Just run up Windows updates, right? As easy as this. But that's the problem is that it's not my server to patch it on. So this it belongs to another service team. And so I reached out to them, obviously, because the system identified critical vulnerabilities on that server, and that also is publicly exposed, right? So there are two issues, right? Existing vulnerabilities that with publicly available exploits, plus that service is configured to face the internet, so it's publicly accessible, right? So in that, what we call toxic combination in this case. So my simple task was to kind of organize the patching process, but since that EC2 server runs the AWS Systems Manager agent, and plus the whole AWS organization that we configured for the client actually has a delegated InfoSec account, which I'm a part of, and I'm like local admin to that account. So I can basically run patches across the whole EC2 fleet, virtual machine fleet in AWS across the whole AWS organization for the client. And the problem is that with documentation, so I never actually use the SSM. It's SSM Systems Manager in AWS. It's a service, and that service has many features. And one of the features is called Patch Manager. And Patch Manager is what's actually should be used here, right? But I never used one for some reason because I relied on other patching technologies, third parties such as Ansible or Chef, right? But today I decided to kind of go with Patch Manager because it's close to the cloud, it's easier to configure. But since I never used that, I needed to explore the documentation. And guess what? So again, Alexander and I, we possess lots of AWS certifications. The hardest one, professional level. Those are really hard to get and to train for. But Patch Manager is something that wasn't, it became available only in 2022 when I was passing the certification. I think it was around that time, but Patch Manager was not part of the certification services on the certification list. So I had to basically explore that. But let me tell you that with my experience with AWS of more than 13 years now, it was kind of hard to grasp an idea of how everything is organized. I got to the bottom of this. I got it working. I got it done. I got an approval from the team, right, to patch the server, and I organized patching from my central InfoSec account to that EC2 server, and I patched not only the operating system patches, right, the Windows patches, but also updated the Chromium browser that they use because it also had two critical vulnerabilities. So that's just an example. Is that it's cloud security is a complex, and it's not is that once the company decides to go to the cloud, they just supply their credit card, pay for the services, and be done with it. So it's a complicated process, and all of the knowledge that you possess from like traditional IT infrastructure with data centers, all of that is applicable to the cloud. It's just a different mindset and responsibility model, right? That we briefly touched a little bit. but we'll explore that later.
Yeah, and we can unpack a famous case that illustrates this. So Sergey has shared his own experience, but now we can jump to the case which was really happened in real life with one of the biggest bank of USA. So what happened in the Capital One breach? So I will say it briefly, and then we will discuss it with Sergey. So an attacker exploited a server-side request forgery vulnerability in a web application firewall path to reach out and EC2 instance metadata service. So attacker was able to send request directly to this client system, and this request reach out internal service. So using this internal service, they obtained temporary IAM role credentials assigned to the instance, and they used these credentials in order listed and download data from S3 buckets, exposing over 100 million personal and financial records. So, I can say so. From this situation, we can get several lessons because the first lesson will be that configuration matters. So lockdown network. So how it was done? Attacker was able to send requests directly to the internal network. So how we can block it? We can lock down network paths so apps can't reach the instance metadata service unnecessary. Metadata service in AWS, it's a service which temporarily store credentials assigned to these two instances. And these two instances itself, it's a common server in common database, data server. So for now, it is recommended to use internal metadata service version 2 because this metadata service requires authentication. But a lot of companies still continue to use this service of version 1. For this service, it doesn't require any authentication. It shares any data for any request. So the attacker used this lack of configuration in this case and get all needed credentials. So what is next? The IAM role, which was assigned to the server, so permissions which were assigned to the server, so it was more than enough. So normally it's necessary to provide permissions according to this principle of least privilege. You need only what you need. But here, attacker was able to get access not only to S2 servers, but to S3 buckets, a lot of them, and other servers. So normally it's necessary to restrict permissions and provide only permissions which you really need. On this case, we also see that the shared responsibility model is a reality. The idea of shared responsibility model is that cloud provider secures the infrastructure, as we have said it previously, but the customer had to secure identity, configuration, and monitoring. So next lesson here, we have care about detect and respond. We have to configure alerts on unusual activities on S3 buckets, for example. So S3 bucket for AWS, it's a storage. And for this storage, it's possible to configure logs and control them using different AWS services. So that's the most interesting lessons we learned here. And as a result, you see that if you don't care about security, if you don't care about your data, someone will hack you sometimes.
Yeah, exactly. And this is what was very like infamous Capital One breach. I think it was in 2015.
2020 to 2019, as far as I remember.
19, okay. So it was not that long time ago. Capital One, again, is one of the biggest United States banks. So let me just give you a little bit clarification of what Alexander was saying, that how that hack happened, right, from the first place, and then how they could have protected that, right? So Alexander already touched on that. I'll be just clarifying a little bit for you to understand. So if you see on the right screen, right hand side of the screen, you see with the images of EC2, right? So those EC2 are virtual machines, just a Linux boxes, right? Where the first one is WAF, is Web Application Firewall. Again, it was configured as a virtual machine, right? As a proxy that's just intercepting the traffic in relaying that to the backend service, which is a web server, here EC2 as well, right? And there's a metadata service. Metadata service is just an HTTP service, but that works only from within the virtual machine in AWS. And those metadata services are available across all cloud public providers. And as far as I'm aware, also there is kind of similar service available in the VMware environment. So it's usually accessible by the IP address of 169.254.169.254. Again, HTTP, no SSL certificate. So, but it only works from within the server. So, for example, imagine USSH, so the Linux server, right? And you go to the curl or wget or any other command line web client, right? And you request that HTTP and that IP address 169.254.169.254, it will respond, right? So it listens locally, and that IP address is reserved from within the AWS virtual machine. It's available in Linux and the Windows operating systems, so it's absolutely the same across different operating system types, and it gives you back the metadata information about the server itself, when it was launched, who launched it, what like SSH public key it was launched with, right? Which IP addresses currently have assigned, which subnet so the whole information, so you can get the most accurate information about that specific virtual machine, right, from within that service. How did that hack happen, and what? And also it provides to the crucial information, and that was what really was crucial in this case, is that this virtual machine that's labeled web server, right? In our case, it was associated with the identity and access management role. So in AWS and again all other public clouds, there is a special role identity called IAM role, right? And that IAM role can be associated with the web server, with the virtual machine, and in that case, it would be called instance profile, virtual machine instance profile, right? And the profile allows you to run, in our case, AWS API calls, right? So, like imagine you are typing from your command line prompt AWS S3 ls command, right, with proper credentials. It would list all of the S3 buckets, right, like the same as we have here labeled S3 bucket, like all S3 buckets for a given account in a given region, even though it's a global service. So it will basically list you all buckets configured in that AWS account. The same API call can be run from within that web server, right, but without any credentials, right? So you associate that role in order not to pass any credential, because it's insecure in public cloud, like went ahead with the security model, right? And all of the public cloud providers, including AWS being the first, right, biggest cloud. So they essentially configured that instance profile that allowed you to run that. What happened here is that, so the first basically step is that some Capital One employee, maybe ex-employee, disgruntled employee maybe, who was offended by the company in some way. We don't know. History doesn't give us those answers. But that person was committing the whole repository of Capital One online banking website, right, to his own GitHub repository, right? So basically given away, and it was public, right? If you go to GitHub, it's completely free to sign up, right, from everywhere where you're located, as long as the repositories are public. If you want to have private ones, there is, I think, limited number, then you have to like pay for a subscription for it. So, or join the organization that pays for the subscription. So in this case, it was public, and the one of the committed files that was committed in that repository was these credentials, right, from that server. And those credentials are not different from the credentials used from the command line. That's the kind of difference. And after and basically that's how the person, so someone discovered that repository, uncovered those keys, right? Decided, hey, why don't I use those keys? And try to use those keys, and they actually work. But those keys didn't contain like the admin level permissions, right? What they did is that this web server also ran basically the web server Nginx, right? It's an open source software, Nginx, and that Nginx can be configured as a proxy or reverse proxy. So proxy and reverse proxy work in a little bit slightly different ways, but essentially it allows you to pass the HTTP request or any like TCP request as well to the backend, and our backend was the EC2 server. So in that Nginx, and I was sitting on the same basically EC2 instance. It's just depicted here as two different entities, but it was essentially a single EC2 instance running the application side and the web server side. So and that Nginx was by default, it doesn't come with that misconfiguration, which was a security threat in this case. It was updated by someone, maybe the same disgruntled employee, right? Offended by someone, we don't know. But essentially, the configuration of that Nginx was configured to proxy anything that was passed to this Nginx server to the backend. In our case, backend was the same application server. Let's call it Java servlet, right? And someone like discovered that vulnerability or misconfiguration and say, hey, why don't I try to go HTTP capital1.com, let's say, /redirect, right, equals HTTP /:/169.254, our metadata service IP address /IAM profile /credentials. I don't remember the full exact path, but you get the idea, right? And he was able, guess what? He was able to get those credentials out of that web server, the virtual machine server, the credentials back to his browser. And wow. And the role consists of three things: secret ID. Alexander, help me out. Secret ID, secret key. So secret name.
Access key, access key, and access value.
Yeah, but essentially username, password, right, and the session token. So three values and the session token. So all three things you copied from the browser in the response, right, from the server, and you decide to use it from within your shell, right? They decided to use that and discovered that this role contained near admin permissions, and that's another misconfiguration. And there's a lot of services to monitor for that, right? And that's what we cloud security engineers actually do to protect the data for our clients. And that's what actually we will be teaching you in our class. And they extracted a whole lot of data from RDS database and 100 million of personal and financial records. And by the way, Capital One was PCI DSS compliant, and they got a big fine. I don't know the number, but I'm pretty sure the fine was very big. It's a good thing that they didn't hide that hack. They basically revealed it to the world, because if they hid it for some reason, like personal reasons, right, they would have been fined much, much more. But there are fines for things like that, for the misconfiguration. But security in this company specifically was really, really bad. So DLP was not working, the data loss prevention, right? So the perpetrators were able to exfiltrate, tons of gigabytes or terabytes of data, right? Without noticing, right? It didn't happen overnight. It happened over like extended period of time. This was a very, very scary situation. And after that, as a response, as far as I remember, AWS, there was a big pressure on AWS. Hey, like from Capital One perspective, we are one of the biggest clients. We pay you millions of dollars to run our operations in the cloud, right? And here, like we don't even understand how that could have happened. Like, why didn't you prevent something like that? Because shared responsibility model. Remember, right? You were responsible for that. But remember, this is an application level, right? So the client is responsible for application side and configuration side. This is the PaaS model. If they would have used SaaS model, for example, if that application ran like 100% on Fargate, which is another AWS service, right? Or Lambdas or step functions, or there is different services that could have been used here. AWS would have taken the full responsibility for this. But in this case, this is a PaaS model, and basically the responsibility lies with the client. But anyways, there was a big pressure from the community, from security community as well, in questions. Hey, at that time, instance metadata service version 2 that Alexander mentioned would have protect that information from being exfiltrated through the Nginx proxy. But for some reasons, AWS didn't push to that. So hey, this version 1, you're okay to stay with version 1 if that works for you. And that's historically has been. That's the first version, right? The legacy version. If it works for you, fine with us. Here's the next version. Yeah, to add some protection, you need to authenticate, right? So imagine like a Facebook website. You go, you basically without authentication and authorization, you go to your profile. That's seems insecure, right? So, and it was the same thing. So the first version was completely unauthenticated. So because that's your box, right? That's your virtual machine. You control it. You SSH to that. You RDP to it, right? So you have proper credentials. Therefore, you could use our metadata service. So that was their judging for that. But after something like that happened, right? They said, hey, yeah, and they now updated their documentation. Instant metadata version 1 is still around in 2025, but more and more companies are trying to migrate to the second version. And actually, I'm running this test right now at my client, and that's I'll tell you, not an easy task. It sounds like very easy, just change an attribute for the virtual machine to the auto-scaling groups, but it's not really this because there is many dependencies on the work level. When you run thousands of or even millions of workloads, virtual machines, right? Different operating system, different level patches, different libraries being used, different select versions. There's a lot of dependencies. But anyway, they updated their documentation now to propose and urgently advise customers to either migrate to the second version of instance metadata service or start working with that directly from the beginning. And they supported that like ask or movement migration with additional adjacent services such as AWS SCP, which is service control policies. And now there is an option to enforce that. So you wouldn't be able, like if you enforce that policy with service control policies on the organization level, no one would be able to deploy virtual machine with the first version of instance metadata service, like never. You would get just authorization error. And that's something pretty good. A config service also supports that. There is Cloud Watch metric available to monitor for instance metadata service version 1 usage across the organization. So they provided a lot of support after this specific hack because it put, again, a lot of pressure to AWS. Because everybody, lots of people, including me, to be honest, I felt that they should be partially be responsible for that because they didn't push enough for that. They didn't warn enough. They didn't, their security architects and threat modelers didn't envision something like that happening to their biggest clients, right? And Capital One still operates in AWS today.
Yeah. And one more interesting thing related to this case, hacker which get all this data from this bank was employee of AWS. It was a girl, and she was AWS employee.
Yeah, I remember. So this was a girl. Yeah.
And she shared information about this breach. She shared this information about this breach near several months until someone found it that she did it. So it was very interesting. Maybe that is one of the reasons why the pressure was to AWS was so big from the community and bank itself, because in case if employee of the company which supports you attack you, it sounds very unusual, I can say. But it's some interesting thing related to this attack, especially. Yeah, so I think we we discussed this topic, and let's answer to one very interesting question here. What could have prevented the infamous Capital One hack? Please, guys, share your ideas after our discussion. What you think, what we could do here in this situation as cloud security engineers, as security engineers.
Let's see who is listening closely to our discussion here, because there's there's pretty much a single answer that's correct. Or actually, yeah, let's see how people are answering. So we have already 12 people on the call. Great. Some people joined on our discussion, but 2 people voted for now.
Okay, guys, please answer to this question. It's very interesting to discuss it then. And let's move to next slide. So let's speak about how cloud security enables progress, how we can help different companies to grow. So cloud security isn't about saying no, as I have said. So it's about enabling the right yes. So the main idea here is to help companies to grow in safe way. So one of the most interesting thing here is innovation enablement. So with guardrails, teams ship features faster and safer. So the idea is that we as cloud security engineers can help different companies uh, develop and ship new features in broad and different environments in a safe mode. So also it's data protection. So encryption, strong identity, segmentation, protect customers' privacy. The main so why we protect something? Why the companies work at all? So each company has something very important in its internal. It needs wishes. Each company wishes to earn money, I can say, and we as cloud security engineers, as security engineers at all, help companies to protect its data in order they can get revenue and in order they can grow. And encryption, strong identity helps to do it in a safe mode. So also, scalability with confidence. When you scale globally, good security reduces friction and fear. Because if you wish to grow, if you wish to go to another markets as a company, it's necessary to be sure that you will be safe. As far as you know, that different clouds, AWS, Azure, GCP, they have data centers in different regions of our planet. So, and when we move to new regions, to new markets, we can move all our infrastructure in a safe mode. And cloud security engineer helps to do it. Helps to do it, yeah. So then the next thing is trust building. When users trust your service, adoption and loyalty grow. As we discussed it previously, you said that you trust clouds. Yeah, when the company is secure, when company pass through requirements of different security standards as far as PCI DSS, HIPAA, or some other. This builds trust with our customers, and only we, cloud security engineers, can help companies to get it. And as a result, we can say that security done well becomes a competitive advantage. It's really advantage on the market because if you provide the same level of service as your uh, as some other companies, but in the same way you are a security company, it means that clients will work with you, will choose you. It's very important for the business. So, Sergey, can you add something?
Yes. Just just some like clarification and practical example of why choosing why cloud security enables some progress and simplifies your work in some way or another. Think about like this is the last example as well, being this favorite cloud among myself and Alexander. Think about the uh, um, defense methodologies from ongoing attacks on the network level. Like think about Christmas attack, if you heard about that. Think about the TCP, UDP flooding attacks, right? Where a bunch of devices like DDoS or DOS types of attacks, where a bunch of devices are sending network packets to your service, to your endpoint, be it a load balancer, directly serving web server on the internet, stuff like that. So you have to, in traditional networks, you have to like basically deal with that, configure router and switches to basically deal with that amount of traffic because it will flood your network and it will congest the traffic from legitimate users, essentially providing your denial of service attack, right, condition. In our case, like AWS, without any additional pricing. So you subscribe. If you don't use anything, you're not paying for anything, right? Pay as you go model. But by default, if you deploy it like a load balancer and the virtual machine sitting behind it, right, or the auto scaling group, like several machines sitting behind it, and these are flooding attack. This is the same thing: Christmas attack, TCP, UDP flooding attacks. It'll be automatically be responsibility from the AWS. You won't be charged a penny for that. So that's the greatest advantage of using security model from shared responsibility perspective in the public cloud providers. The same thing with advanced types of attacks. That's also automatically covered by AWS Shield service. That actually comes with no price, and there's like two models, standard and advanced. The Shield standard comes at no price for absolutely all customers, and it protects your services at no cost, like on a low level. Advanced level, it's a pretty pricey service, as far as I remember. It's close to $1,500 to $2,500 per month, I believe, even per account. So that's pretty pricey service. But it gives you a whole lot of like ways to protect your data, including the HTTP, the application level, right? And there is a 24/7 available incident response team from AWS. From within that service, but you have to pay for that. So those services are available, and those services and those services are cloud native, what we call, right? So those services developed by the cloud service provider themselves, so they know their stuff much better than anyone in the world, right? While like protecting your data in traditional data centers will require you purchasing some off-the-shelf third-party solutions that might work in some cases even better. I mean, but in most cases, they will not work as nearly as effective as cloud-native tools and services, and most effectively too. So let's say the event bridge service that captures all of the logs and events that being generated by the AWS cloud is the fastest service you can find. Like you can compare it with non-AWS native, so like third-party commercial service. It will not be as fast as possible. If your objective is to protect your data in the most effective and quickest way possible, right? The cloud-native service is the way to go. All right. At the same time, we have 5 people responding, voted to our last poll. Let me read the results. So essentially, all of the all other poll questions, all of the questions are pretty similar, but one is better than the other, right? The best answer is all of the above, and 3 people I see responded to that, while one person said migration to EC2 Instance Metadata Service v2. The second version of the service on the organizational level will help that. Yes, it will help. All right. So if you migrate it, that would have been exploited, but the misconfiguration would still be there. The Nginx proxy will still pass through all of the requests back to the server, even though they wouldn't be able to exploit the first version of Instance Metadata Service. If the whole issue would have been mitigated, yes, but the best, again, the combination of all 3. The second one, secure web server configuration. Basically, don't do any custom configuration. Just do just go Nginx, best security practices, right? Or best secure configuration, and Google it, and you will see basically pretty much the correct answer, right? Or don't do anything. So in that case, they actually added the line that wasn't in best practices whatsoever, but it's supported. In some cases, it actually works, but not for public services, of course. The third answer was mature DevSecOps practices that would have detected all misconfigurations. Yes, exactly. So because if you think about DevSecOps practices, which also entails having infrastructure as code as part of your infrastructure deployment strategy, right? So it would have detected the misconfigured Nginx proxy configuration. It would have detected the usage of Instance Metadata Service 1, right, and everything else. So, and the right answer was all of the above. So basically, if you have all of the above, the migration to Instance Metadata Service 2, the proper Nginx configuration, and the more mature DevSecOps practices, it would have been awarded 100% in put the company to the next maturity level from security perspective.
Yeah, Sergey, thank you. So guys, and if you are considering a career in this space, there is a huge opportunity. So let's check it. You see that today cloud security expertise is in high demand because threats evolve daily and business need guidance. This field offers meaningful impact and strong career growth. So you see on this slide example of salary ranges. They vary by region, company, and experience. So for example, for cloud security engineer, roughly mid high 5 to low 6 figures at entry level, scaling into the highest six figures at senior level. For cloud security architect, generally higher due to breadth of responsibility. For DevSecOps engineer, blends development, automation, and security, and strong demand. And what's behind those numbers is scarcity of talent, increasing regulatory expectations, and the strategic importance of secure cloud adoption. So the main idea here is that, yeah, we have good salary. I mean, cloud security engineers have good salaries, but we are responsible for the protection of company data, of company infrastructure, and it's very important. So in order to earn this money, it's necessary to spend a lot of time in order to get new knowledge, new information, uh, teach how to use it properly, and as a result, you will have it. So, Sergey, what do you think about? Do you think about it?
Yeah, definitely. Those numbers are very indicative, right? So you can see that the ranges are in pretty high level, on pretty high level. To become so again, I'm a cloud security architect, right? And I teach the security architecture course. That's obviously very close to the cloud. It will be cloud focused, but to become the cloud security architect, you can really become right from the college or university, right? Because you will need to get the proper technical and practical hands-on experience being the cloud security engineer. So starting with engineer, but the numbers look pretty great here. Cloud security engineer and DevOps engineer, very close notions of pretty much doing the same thing. Well, DevOps, DevSecOps is kind of so it's well, basically our course will teach the basics of DevSecOps for sure, and so basically all of these three roles will be available to you. I wouldn't say that security architect will be possible, the entry level, but I've seen people who are very dedicated to cloud security and the DevSecOps practices maturing to an architect level in just 1 year. So with hands-on experience with a good project. So all the possibilities are here, and you can see that the projected growth in next year, it's even higher, right? So the salaries keep growing for that role.
Yeah,
And also, yeah, I could mention if you go to those to some of the like headhunters or whatever, talent search engines you have available in your country. Just take a look at how many the demand for cloud security engineers versus for someone like forensics investigator. For some of you who participated in our last podcast, it's very exciting career, right? But there is not too many positions available or demanded on the market because those are really, really rare skilled engineers with very high salary, but not enough positions, right? So usually those guys come from someone like cloud security engineer. The cloud security engineer, the entry level is the pretty much best position you can get in security.
yeah,
If you decide to associate your career with cloud security, of course.
Yeah, and guys, beyond compensation, the work itself is engaging and purpose-driven. Let's check. So, why you should be passionate about cloud security? So cloud security lets you solve real-world problems. It's true. So protecting both business and individuals. Then work with cutting-edge tools like AI-driven detection, cloud-native controls automation. So AWS developed a lot of new services which using artificial intelligence and other new technologies, and you are able to touch and work with it. So make high impact decisions, preventing incidents that cloud affect millions. So in any company, almost there are a lot of clients, and your decision will affect them. And you can do everything, and you can think about it as you are protecting them, and you are responsible for it. Shape the future. So multi-cloud, hybrid, containers, and serverless are redefining best practices, and you can help write the playbook. You can help to develop. You can participate in different communities. You can share your ideas, and you can change all these features because AWS, it's a company which AWS, Azure, GCP, all these companies try to grow, try to change according to the request of the time, and you can help them to do it. And if you like continuous learning and meaningful results, this is your arena. And not to succeed, we must. So that is the idea why we like it. So I don't know what Sergey think about it, but for me, it's really a pleasure to work with it. And I was in several situations when my decisions helped companies, saved companies. So we had several type of attacks when we had to change the configuration of web application for Evolve, for example, which was provided as a server by AWS cloud, and my help said the company protected it. We stopped the attack. So it's very interesting. It's very passionate. Sergey, do you want to share something, or we can
Yeah,
continue?
fully agree with that. Yeah, let's continue, please.
Yeah. So to succeed, we must understand how responsibilities are shared. We already took this topic, but let's dive in. So in the cloud, security is shared. The provider secures the cloud itself, physical data centers, hardware, network, and foundational services. And you secure what's in the cloud, your identities and access, configurations, data, applications, and how services are used. So as example, we already discussed the breach, but as example, if an S3 bucket which belongs to you is storage is accidentally made public, that's on your responsibility. That's the customer configuration, not the provider's infrastructure. Understanding it, understanding this model, like AWS shared responsibility model, helps you focus your energy where it counts. So when you understand how cloud works, it allows you to spend your time on the topics, on the task which you really need. Uh, for case we already discussed for Capital One, looks like guys didn't understand this approach properly. Uh, It's very important to dive deep into it, and we will touch this topic during our course. Yeah. Sergey, do you want to add something?
Yeah, just to reiterate, so as you can see, this is the specifically AWS shared responsibility
Yeah.
model, but the same responsibility model is available to other cloud providers. Yes, and as an example for securing the S3 bucket, so AWS will be responsible for hardware, AWS global infrastructure. It will be responsible for access from other clients in AWS. So the client with another account ID that's not part of the organization will not be able to get data from your S3 bucket because it's yours. That's their responsibility. That's we don't have anything. We don't have to do anything with that. But it's our responsibility to protect public exposure of that S3 bucket, and that's where customer responsibility in blue, and that's basically a second block from the top, the identity and access management. Access management is what we are responsible for. Each S3 bucket comes with a few, and the S3 bucket being one of the oldest service, right, along with Route 53. So those are really highly scalable and accessible. It's they have basically 99.99911 availability time. So, but at the same time, there's quite a few different methods of securing them in terms of access management, right? And S3 bucket is are really flexible in terms of what data we can store them and what services we can have the data available to them. But it's our responsibility. And by the way, like a few years ago, AWS made a migration in S3 bucket specifically to make all S3 bucket created by default, secure by default. So before that, when it created bucket, it was your, according to this model, right? It was your responsibility to make it secure. But now, if you don't know nothing about cloud security, but you want S3 bucket and store your data there, you create it, and it's already secured by default, unless you go and tweak something in it, right? So basically, again, it's your responsibility because that's something you control. But now, at least they made it private by default, because before that it was public by default. So at least they did a great move in this direction.
Thank you, Sergey. So what will you learn in this course to operate confidently in that model? Let's check. So here's what we'll cover: hands-on and conceptually. It's identity and access management, IAM, strong authentication, least privilege, and roles across AWS, Azure, GCP, securing multi-cloud, consistent guardrails, policy as code, and visibility across providers, Encryption and key management at rest, in transit, envelope encryption, and KMS, HSM use. Cloud security architectures, it's network segmentation, zero trust, VPC, VNet design, private access patterns, real-world incident response, playbooks, detections, forensics in cloud-native logs and services, threat modeling this right. So we will find issues before attackers do. Endpoint protection in cloud, protect workloads, containers, and serverless entry points. Vulnerability management, from misconfigurations to patching and container image scanning. By the end, you will know how to design, implement, and validate practical controls. So, are you ready to make the cloud safer? If you're ready to
Yes,
dive
we
in,
need
let's
you.
wrap up. Yeah, this is a bigger vision we are taking on. We are really securing the future. So, guys, I can say from my practice, real experience, that it's really very interesting because I worked in banks, I worked in data centers, and then I moved to clouds, and it's more interesting. You are only facing with tasks which allows you to grow, which give you an opportunity to think, to imagine, to develop something. In all technologies, everything was structured as this. You can't change anything. There are a lot of rules. In clouds, everything is changing. Everything is new. It allows, it gives you a lot of opportunities to grow as an engineer, as a person. So as for me, I like clouds. As
Yes,
engineer, it's
and also good to point like the differences between operating in traditional data centers versus clouds. In AWS specifically here, being the biggest and the first public cloud available to the public, is that everything that you do in the AWS console, right? Every click, every configuration option you choose is available through API, right?
yeah,
So it doesn't. So now you don't need every time to rely on your browser, to rely on like your knowledge of the console. You can see you can script everything, right? And so actually, that's what modern DevSecOps engineers do, right? We script everything, right? We instead of like deploying in like a single server using console or the auto scaling group, whatever service we need to deploy, we do it in Terraform, right? So there's different tooling, and now obviously we learned Terraform, we learned how to protect Terraform, we learned vulnerabilities introduced by Terraform, right? We introduced how to protect against those, right? The different services appear that we took advantage of and leverage now in our clients, in our CI/CD pipelines, right? So, and essentially becoming DevSecOps engineer. So I consider myself before becoming an architect, cloud security engineer slash DevSecOps engineer. So I kind of mix those things together because you naturally will expand your knowledge by going into DevSecOps sphere, right? And this course and all of these topics listed here will be essentially split and covered in more or less details across cloud security module, cloud security, for, I don't remember how it's called correctly, cloud security, basically for beginners to cloud security advanced course, right? All of those will be topics will be covered by Alexander in 2 different semesters, first and second semester. And the big advantage of that, like even comparing with the certification that we with Alexander passed, the professional level solution architect and security architecture one. Those don't teach how to apply. Those will
yeah.
teach you how to use the
It's not
service, right?
about real practice, guys. It's
Yes,
about
exactly,
knowledge about how to push
exactly,
buttons or run something, but
exactly.
real experience in something which you can get only from guys who already have this experience, and we can share it with you.
Yes, and that's exactly what we're going to share. This is the basically the benefits of using this program because you will not only get the knowledge provided by basic security practices by the vendor themselves, but we also will be passing our experience, and
Yeah.
that's most important. For example, securing multi-cloud environments. So there's
Yeah, we
not
have a lot of topics related to agnostic technologies which are available on the market today. It will be rather
yes,
interesting. So we have solutions which can be work and applied in both GCP, Azure, and AWS. But for example, AWS, Azure GCP itself, they don't share this information with the clients. But we will share with you it. We will teach you how to
yeah,
use agnostic technologies in order not to depend on clouds, but working in clouds. It depends on business your company can have, but it's still rather interesting, and you will get this knowledge.
Yeah, during the courses, during our classes, online classes, we'll be passing the knowledge in our experience based on the successes and failures as well, right?
Yeah.
So when we tried this, it didn't work. So you really can get that wisdom from us, right? So you don't try because it didn't work for them, right? And they worked for the different business domains for many years. So we should have been using this, right? So so basically you become an expert much faster. So that's our goal.
Yeah,
We
guys,
want you to join our club.
yeah, let's guys move to next slide. So this slide is about securing the future together. The main idea here, why we make future. So cloud security isn't just a technical skill, it's a responsibility to protect the world's digital infrastructure. So together we can reduce risk, build trust, and enable innovation. And I can share with you one example where cloud security engineers helped a lot of companies. Maybe you remember the log4shell vulnerability that hit the news. And this vulnerability had very high critical level. It was 10. It allows to send commands directly to the applications. We will not speak about what was it, but about how cloud security engineers helped to remediate this issue. So first hour when it was published, uh, Cloud security engineer pull cloud provider advisors. They enable managed WAF rules. They block outbound LDAP, RMI at VPC firewall to cut exploit fast. So the idea was to protect our applications controlling the network path. Then they find exposure fast. They kick off dependency scans, query cloud assets inventory to look out internet-facing Java log4j log workloads. So the idea was that we as cloud security engineers, we know the infrastructure for our clients. We understand where and how each service is running. And when we get information about this vulnerability, we know that it's Java, that it's log4j library. We know where it is situated, and we can help to block it to protect our client. So contain risk. So isolate high-risk services, tighten IAM on affected roles, and rotate secrets. As we see that we are not able to protect application itself, we can mitigate the issue. We can try to isolate it. We can try to tighten IAM rules. So we have a lot of ways how to protect our clients. We can. The next step was patch and ship safely. So we partner with dev to bump log4j and disable GNDI lookups, fast track fixes through CI/CD with scanner releases. So we gave recommendations to dev teams how to fix it. They changed the code, deploy it using CI/CD pipelines, test it fast, and then deploy it in production. And we did it very fast because we get all needed information from clouds, from vendors, and share it with our teams. So detect and assure, add alerts for GenDI payloads and unusual egress, watch logs, tune rules, and share IOSs back to the community. So all these things was done by cloud security engineers. So this role matters. I can recommend you as a cloud security engineer that you have to build your collective defense kit, subscribe to cloud provider security bulletins, keep an up-to-date asset inventory, enable managed WAF and baseline detection, practice in incident playbooks. So guys, thank you for your time. I'm excited to work with you in the course. And now we will give some time to our organization team, and we are waiting for your questions in order to discuss this conversation. Thank you very much, guys. I'm stop sharing.
Thank you so much, Alexander. Sergey, your experience impresses, and both EPAM is happy to have you as practitioners, and IT Park University is happy to have you as guest professors. I see that we have people on the call who are not super experienced in cloud security. Anyway, the questions in the chat or in Q&A, or you can raise your hand and talk to our experts, would be something that is much appreciated. And talking about the program we offer, and that could be a good start in your career, is about cybersecurity architecture and cybersecurity management. So the program itself starts at the end of September. You still have some time to join, and you can have a look at what we offer, but for the courses that are taught by Alexander and Sergey. The program is full of professional courses needed for you to get the profession, and absolutely something that gives you the solid background of acquiring a new job role. It lasts for a year and a half. It's fully online, which gives you the freedom of online work further, as IT is mainly online, and you can be joining the program from anywhere in the world. If you've been thinking about information security, cloud, so here you can consider this, because they can be the career advancement, and your confidence, credibility can be higher, and you can get the job which is popular these days and would keep being popular, I'm sure, more and more. We always get the questions from people who want to join master's degree. What can I do after? What can I do as a job after? You can have a look at the employment opportunities and jump into cybersecurity architecture or consultancy, being the manager of the teams, and diving deeper into information security. And while I'm inviting you to fill in the form if you're interested, and if you want your personal consultant get back to you and answer all the questions about admission, I'm checking if there are any questions in the chat. There are no, just thank yous. Fantastic. Then my question to Alexander and Sergey: as we see, we have the team of juniors joining us today. If a person who has never practiced information security, if the one joins the program because one has the bachelor degree, would it be doable for a person after finishing master's? So first of all, would it be doable to study at the program? And second of all, would it give a person a chance to obtain a profession? So, gents, what do you think?
Absolutely. Absolutely, I think because we all started from somewhere, obviously. So our objective, our course in cloud security specifically, will, again, as we mentioned already, pass our skills and knowledge and experience, most of all, to you, right? So you can learn from our mistakes, essentially, right? And all of the experience we pass to you. But there will be lots of reading. Obviously, we'll be recommending to pass those specific, whoever will like to join their careers with AWS specifically to pass. We'll be given specific recommendations and given specific materials to prepare to pass the certifications, right? Those certifications will definitely help, because again, as I repeat myself, no one knows better the cloud and its security features and like nuances better than the vendor itself, right? So definitely, we'll all start from somewhere. It will involve a little bit of learning, but if you're excited, as we once were when we began this career, you'll be more than happy to be part of this class, of this cybersecurity program, because we will teach you a lot. Yeah, and in cloud security specifically, as again I briefly mentioned, cloud security goes through our courses. So no matter which course you take in any given semester, the cloud security topics will come through that course. So like AI, right? It will cover the AI and security, and it will be connected to the cloud. My course, the security architecture, obviously will be pretty much about the cloud, right? Being the cloud security myself, and all other security development. So Alexander, our other professor, will be teaching the shift left approach, the secure SDLC principles, but they also will be connected to the cloud, because now these days secure SDLC also connected to the cloud as the deployment as the deployment model.
And I can add here that modern clouds, especially AWS, are very human-friendly. It means that if you wish to get knowledge, if you wish to get practice, it's not a problem. You will get it because cloud itself provide anything you need for it. Interface is very easy. Command line is also very easy. So there are a lot of documentation and information. And we as teachers, as your teachers, will share with you our real experience, and it will be advantage for you. You will not only got common knowledge, which shares by AWS, but we will add to this knowledge your experience. It will work, I think. Don't worry.
Awesome. That sounds fantastic because at the beginning of the session, I had a look at the participants and guys were sharing where they are in informational security. And I thought to myself, would it be okay if guys are nota bene and join the course studying everything from the scratch? And the answer is yes, which is very inspiring. Gentlemen, you've been very passionate during our podcast, and I'm sure those who join the course master's degree would be really happy and as well inspired to work in this field. And thank you all for coming and joining the podcast today. There will be the recording of it, and I'm really grateful to those who'll be watching this video. Please be sharing with your friends, with your family who've been thinking about obtaining a new profession, and a fresh start with master's degree could be the step that would bring you to online, very happy, satisfied, and exciting future. Because what guys have already mentioned, sometimes the security of business depends on such specialists, which is, I'm sure, stressful and interesting and exciting on the other hand. The longer you stay in the profession, the more you need the variety, because people are burnt out not only because they're tired and they have a lot of stress. People burn out because they are bored. So you will never be bored in this profession. That's I'm sure in. Okay, thank you. I see that you have left your contacts for our consultants to join you as per masters. Please follow EPAM and IT Park University pages in LinkedIn, Instagram to join all our free events we're doing for knowledge sharing. Thank you one more time, Sergey, Alexander, for doing a great show. You should absolutely do more. And we will hope to see you at the program. Thank you, guys.
Thank you, everybody.
Thank you.
We'll see you in our program.
Goodbye. Yeah.